Hello students, welcome to Apna Tutor channel. I'm your Mehak ma'am and today we'll be discussing about another topic of class 12th electrostats chapter, that is electric flux. So we'll be understanding about this topic and have insights of the topic, right? And we usually denote it with symbol phi. So this is the symbol of electric flux. Now let's start with the topic. Suppose we have this planar surface over here. So what is electric flux? Now if we say that some electric field lines are crossing through the surface, so let me show you some field lines. So these are some field lines which are crossing through this plane surface. Now we know that in the last classes we have studied that the how these electric field lines are originated, or what is the source of this field lines. That is, the source of the field lines are the point charges which are at rest, right? So maybe a point charge can be kept at some distance and originating the field lines, and the field lines are crossing this planar surface. So what will be the electric flux is it will be the number of field lines which are crossing the surface area. Okay, so the number of field lines, it is a measure of number of field lines. Of course, if I change the orientation of the surface, so the number of field lines will change, and we'll see in a while how they are changing. Now let us suppose this planar surface have some area A, and we'll see that here area will not be a scalar quantity now anymore. It will be a vector quantity, and we'll understand it about in a while. So suppose this is the area vector, and this area vector will be having some magnitude as well as some direction. So magnitude will be magnitude of this area vector will be area of the surface. We know that how we calculate area, right? That will be our magnitude. And here direction will be either positive, we can say positive normal to the surface, or we can say outward normal to the surface. Outward normal to the surface, right? So what is the significance of this outward normal? I should have said normal to the surface also, so it would also have made some sense. So what is the significance of this outward term? Suppose I have a spherical ball. Let's assume that I have a spherical ball over here, and now if I ask about the normal to the surface, to draw the normal, so you will say, okay ma'am, we can draw normal to the surface in this way, either in this way or in this way or in this way. Means any pointing arrow perpendicular to the surface is normal to the surface. Either it can be this, or it can be this also. Okay, so these all are normal to the surface. But what we have to consider is, we have to consider the outward normal. Outward means the arrows which are pointing outward to the surface, these all. Okay, so these are outward normal to the surface. These will not be included. Okay, so it will be inward normal, and it will be pointing inside the sphere, right? So they will not be, they are normal, but they are not the point of consideration in our topic, right? So this is one of the important point, and it will help in are numerical questions, right? So keep it in mind. Now I hope you are clear with this area vector, and I can say that this area vector is a vector quantity over here. Okay, so in your NCERT, it is, this topic is considered analogous to the fluid flow, or either the water flowing through the pipe, or any surface, means how much is the water flowing over the surface. From there also we can understand this, right? Now we have seen that this flux, which we are denoting it with phi, so it is directly proportional to the, means it depends on the electric field, right? It will be, as we are seeing, that the number of field lines, so it, of course, it is depending upon the electric field lines. Okay, so it is also depending on the area vector, and of course it is depending on angle. As I earlier mentioned, the orientation of the planar surface is one of the important major factor. So it will be equal to cos theta. Now we can write it as E dot A. So it is the dot product of the electric field and the area vector, and this whole quantity, this flux, is now the scalar quantity, right? Now let me show you with some animation so that it will be clear to you. So in this video you will see that electric field lines are being originated from some plane sheet. So we'll study how the field lines are originated from the sheet in the later part of the video, but let's focus on the electric flux right now. And these are passing through the planar surface that is shown in this green line. This is a planar surface, and you have to focus on this arrow which will be changing the orientation of the planar surface, that the angle will be changed from 0 to 45 and 45 to 90. Therefore you have to observe the electric flux. So at 0 degree, our cos theta will be cos 0, that is 1. So E naught A, and suppose we have considered some value electric field to be 5 Newton per coulomb, and surface area also we have considered some arbitrary, that is 10. So while substituting the values, we'll get the 15 Newton meter square per coulomb. This is the unit of the flux, and we'll see that this much of the flux is crossing through the surface area right now at this angle, and you have to observe how with the change in the angle this flux is changing. So let me start. Now as the angle will change from 0 to 45 degree, so here the flux is changing, and from 45 to again 90 the flux goes to 0, and if I again change the angle, it again changes. So cos 90 was 0, so there will be no flux at that point of time. So we can also see it pictorially. Suppose this electric field, this is our planar sheet, and from this sheet electric field lines are crossing, and of course this is our area vector, which is normal, and it is outward normal. So electric field and area vector direction both have theta equal to 0 degree, since both have same direction, electric field and area vector. So it will be, if we apply the formula EA cos theta, so cos theta, theta will be 0 and angle will be 1. So we will be having this value. Similarly, if we change the orientation to some angle theta equal to 30 degree, then we'll have this value. And if theta changes to 60 degree, and if theta changes to 90 degree, suppose now our electric field lines are in this direction and our area vector is perpendicular. So now the field lines will be 0, means the flux will be 0, since no field lines will be crossing through the surface, as we have seen in the video, right? So it will be maximum when the surface is perpendicular to the field, and 0 when parallel. So it can be negative also. depending upon the angle. So in this video we have discussed about the electric flux, and we have talked it is a scalar quantity and its units are Newton meter square per centimeter, or we can say it as volt per meter, right? And it is equal to E dot A. Okay, so now till now we have seen that the electric field was uniform. Of course, we have seen uniform electric field. See, now what happens if we have non-uniform electric field? So for the non-uniform electric field, flux will be electric flux in non-uniform field. Non-uniform field. So this is our concept number 2. That was concept number 1. And non-uniform electric field, suppose we have again some planar surface and some non-uniform electric field lines are crossing, right? What we'll do is we'll take again the area vector which is pointing outward normally like this. Okay, so we'll be taking a small area element, right? So from that area element we'll say that it will be small dA vector, and the angle between E and A, so this is some any of the electric field line which is crossing the plane. Okay, so it will be having some angle theta. Okay, so d phi we have to calculate. So it d phi will be for this small element. For the smaller element, d phi will be, that is flux element will be E dot dA, right? E dot dA. So we'll be integrating in order to, now integrating it will give the total electric flux, right? So electric flux will be E dot dA. So it will be our flux that will be from the non-uniform field. Now in the next class we'll understand the Gauss law, which will be easily understood if we understand this electric flux quantity. Okay, so in this video we'll study till here, and till then keep learning. All the best.